Find the general solution to this linear system. So our first step is to write the augmented matrix. And you can see I'm just writing down the coefficients in alphabetical order, putting the numbers on the right-hand side. Okay, so now we want to row reduce this. So we perform row operations on this matrix. Now we already have a 1 here, so we'll use this top left entry as our pivot. So let's multiply the top row by 4. And so next, let's replace row 2 with the sum of row 1 and row 2. So we have 0, 6, 3 minus 3. Let's now replace row 1 with 5 over 4 row 1. So we cancel the 4's in there and we end up with a 5 in the top left, ready to deal with that bottom left entry. Okay, now let's replace row 3 with row 1 plus row 3. And let's replace row 1 with 1/5 of row 1. Now you can see that row 2 and row 3 are identical, so we can replace row 3 with the difference of row 2 and row 3, and replace row 2 with 1/6 of row 2. We have a row of zeros here. Now this is not yet in row reduced echelon form. We need to have a 0 above this second pivot. I will circle the 2 pivots that we have here. There's no pivot in the third row. Okay, and so next, let's replace row 1 with row 1 minus row 2. So now we have a matrix in row reduced echelon form. Okay, so we have a row of zeros. So this is underdetermined, but we can do something with this. So now what we will do is write corresponding equations from this. And so this says x plus 1/2 z is 1/2, and the second one says y plus 1/2 z equals minus 1/2. Okay, so what we want to do to find the general solution now is we'll let z be equal to a parameter, say alpha. Now what we can do is write x in terms of alpha, minus 1/2 alpha plus 1/2, and similarly y is minus 1/2 z, which is minus 1/2 alpha minus 1/2. Okay, now z, of course, is just alpha. So putting this all together, what we have then is x, y, z, let's put this in a vector, is equal to minus 1/2, 1 times alpha plus 1/2 minus 1/2, 0. And here's our general solution where alpha is any real number.